All right, today what we're going to do is multiply and divide radical expressions. All right, now just to review, if you had a problem that said 2 to the third power times 2 to the fourth power, how can you simplify this problem? 2 to the third times 2 to the fourth, what would you do? You do 2 to the 7. If bases are the same and you're multiplying, you keep the base the same and you add the exponents, right? Well, did you know that if your bases are different and your exponents are the same, did you know that you can do this? You can, if you're multiplying and the bases are different but the exponents are the same, you can multiply your bases and keep your exponent the same. So in other words, 2 squared times 3 squared would be 2 times 3, which is 6, 6 squared. Did you know that? So similarly, see this right here? If you have the cube root of 4 times the cube root of 5, it's the same as the cube root of 20. That is the same as this problem right here. You can, since these are the same indexes, what you can do is multiply what's underneath here, and you've got the cube root of 20. Got that? And then you would simplify. So here's the product rule. If the indexes are the same, what you do is multiply the radicands. So A times B would be AB, and you keep the index the same. Everyone got that? Now, look at these examples. So problem 1. Could you do this first problem? The 4th root of 7 times the 5th root of 7. Can you do this problem? You can. Are these the same? You can't do this one.
First thing you check.
You want to see if these indexes are the same. You can't do this one.
Oh, if the bottom ones are the same?
Nope. Nope. If the indexes are the same, then you can combine these two. If this were a 5, we don't care about what's underneath it. It's the index has to be the same. Check the next one out. So this one. Are these indexes the same?
Yes.
So you keep the index the same, and you will multiply these two right here. What is negative 5 times negative 2? Positive 10. Okay? Let's do a few more. How do you do this one? Are the indexes the same?
Yes.
Yes. How do you simplify these two? Can you multiply those two?
Yes.
And what do you get? No, not 8i. Cube root of negative 8.
And then
Now
the baby
remember
squash.
last Tuesday, going back, first of all, this would not involve an I. This is just the cube root of negative 8. You're thinking of square root of a negative number.
Okay.
You're thinking of something like this. If you have that, then it would be 2i, right? Okay, now we said last Tuesday that we are not using imaginary numbers in this chapter. Do you remember that? Does anyone remember me saying that?
Yeah.
We are not using imaginary numbers. So if you see the square root of a negative number, it's no solution. You can't take the square root of a negative number. Anytime the index is even, and there's a negative number here, it's no solution. So we're back to, you can't do a negative number if the index is even. So think back, no more i's. You're not allowed to use I imaginary. Can you take a negative number if it's, yeah, what's this answer? Good job, negative 2, good job. How about this one? Can you do this one?
No.
Why not?
Because the 3 and
Indexes
the
are not the same.
Not
I'm not
possible.
doing it.
The indexes are not the same, so you can't do that, not possible. How about this one?
Yep.
This one you can do. Now, I'm going to give you a suggestion. Now, I just told you that you should multiply these two numbers together, right? 9 times 27 is what, 243? Okay, so, but I'm gonna give you a better suggestion. I have an option. Instead of putting these two numbers together, keep them apart, because what you're going to do is you're gonna break them down, exactly. So 9 is 3 times 3, right? And what is 27?
3 times 3 times.
Mm-hmm. What does fourth root mean? What are we looking for? 4 of a kind. 4 of a kind. So all you have to do is look for 4. Do you have 4 threes?
So it's 3, 4 root of 3.
Yep. It's, no, wait, say it again.
3, 4,
3,
square root, and then 3 under.
4, yeah. Like that.
Yeah.
So this 3 is what came out right here. And then we have a 4th root, and this 3 is what stays. This had nothing to partner up with.
And for those of you that want to brush up on that math language, it's 3 to the 4th root of 3.
Mm-hmm.
That's how you say that.
Okay. So these next 6 you're going to do for homework. Try this one. We have the cube root of 127 x to the 7th. Now,
28.
we are looking for 3 of a kind. Can you break up 127?
128.
I'm sorry, 128. I looked at that 7.
I know. That was,
Now, this is an even number, so I know 2 goes into 128, right? How many times does 2 go into 128?
64.
64.
8.
And then you could do 8 times 8, and then 3 2s, 2 2 2, and then 2 2 2. So how many 2s do we have?
7.
7 of them. 1, 2, 3, 4, 5, 6, 7. Now,
You need 3.
Put
so you
dots
can
in between
take
all of
2
those
sets
things.
of-
and now how many x's do you have? 7.
Shane.
I'm going to show you a couple different ways. Okay, did I count 7? 1, 2, 3, 4, 5, 6, 7. Now, look at the index. You're looking for 3 sets of, you want 3 of a kind. So there's one
You have
set.
2 sets.
You have 2 2s, and you have 2 x's. So what comes out? What's coming out of the radical sign?
2x.
You got a 4.
2, it's 4.
2x 2.
And you got x squared, right? What stays?
The 2x.
Don't forget cube root 2x. Now, check out this variable x to the 7th power. Here's another way you can do this. If you don't want to sit there and write 7 of these x's out. Do you remember last Tuesday I told you how to rewrite? How do you rewrite the cube root of x to the 7th power? I'm going to do this on the side here. The cube root of x to the 7th power. Do you remember how I told you how to write this as a rational
So you take the
Exponent.
exponent of the number on the inside.
So,
over the-
yep, the index is the denominator, the exponent is the numerator. Can you turn 7/3 to a mixed number?
2.
2 and
1.
1/3, right? So the whole number here is what came out, x squared. How many were left? The fractional part is 1, so x to the 1st, that stays underneath the 1 part, and the 3 is the index. So if you want to do it that way, that's fine. Did you have a question?
Yeah, why is it x squared and not just x?
Why is it x
Because
squared?
there's 2 sets of
Oh,
x's.
because there's 2 sets of them. You have 7 x's. 1, 2, 3, 4, 5, 6, 7. you're looking for 3. Every time you get 3 of them,
You pull it out.
you pull that one out. So you got, here's one set and here's another set. So you got
So-
x squared.
If you wrote the intermediate step, it would say 2 times 2 times x to the cube root of 2x.
Got
And then you
that?
simplify.
Okay. I want to do these next 3. They get a little bit more challenging. Okay, so what do you want to do for number 4?
Two.
Any suggestion? First of all, can we do this problem?
Yes.
Yes, because they're both cube root. So, if we were to multiply these two numbers, is it going to be positive or negative? It'd be negative, right? Negative 54. Can we take the cube root of a negative number?
Yes.
Is it going to come out negative or positive?
Negative.
So I know my answer is going to be negative, okay? So let's not deal with, let's just, the negative we just dealt with. So this is going to be 6. 6 is 2 times 3. And 9 is 3 times 3. Don't try to make this, a lot of people will say negative 3 times negative 3, and that's going to be a positive 9. So that might mess, just think of the negative 1 here as the negative that comes out. So, I'm looking for sets of 3. Do you have any 3s yet? 3 of a kind? There's 3 3s right there. So the 3 comes out. Is there anything that stays?
The 2.
2.
So what I do is I make my cube root, leave some space here for my, if I have any x's that are going to come out. And what stays is my 2. Now check out my x's. How many x's do I have? How many? 2 and 3 is 5. I have x to the 5th power. So I need the cube root of x to the 5th. So if you want to write it as 5/3 and then turn it into 1 2/3, do you guys like doing it that way or writing it out?
Well, I think because it says x to the 5, like it's easier to visualize than you have 5 x's, right?
It's up to you. I don't care. If you want to write it out, whatever you want to do, whatever is easiest for you. If you see it as, you see 5, if you see x to the 5th, this is x to the 5th, and you see 5 x's, 1, 2, 3, 4, 5, and you want 3 of them, you take that x out, and then you have 2 left over.
See, now when I'm looking at that and I see x cubed, hey, that's a cube root. I'm pulling
Yeah.
out my x and my leftover is x
Yeah.
squared.
Yep,
Why
and
should
that,
even-
yep, you can take that out there, and then those two, there's so many different ways to do this, yeah. Anyone not get that? Ooh, big numbers here.
2, 3.
Okay, so, a lot of different ways you can approach this. We're looking for square roots.
I look for perfect square factors.
So 48, I'm gonna break 48.
2, 3, 2, 7.
6 times 8 is 48. 6 times 8, and then 2 times 3, 2 times 2 times 2, and then 50 is 2 times 25, 5 and 5, right? So what do we have here? Let's do my numbers first. I've got a 2 here, another 2, that's 4, and a 5. So 4 times 5 is 20, is that right?
Yes, ma'am.
And what was left? 6, right? I'm gonna put a 6 over here in my square root. So my numbers are done.
That 6 should be in your square root,
Oh. Yeah. Thank you, Miss Burbank.
right? You're welcome.
Okay, now my x's. How many x's do I have?
7.
I have 7 of them.
So 3 sets of 2.
So I have x to the 7th. So do you want to write it out? 1, 2, 3, 4, 5, 6, 7, and then go 2 at a time? So you have x to the 3rd here, and 1 left over. Is that easier for you? How many y's do you have? Y to the 6th,
So just 3.
and then you have y to the 3rd. Is there any left over? Oh, that's your answer. Last one. What are you gonna do here? I see a 2 and a 4 standing outside. What do you do with those two? What's these two, what's this all about? These are just two numbers standing outside, they get multiplied together. 2 times 4 is 8. So when I pull something out, I multiply it by 8, right? Okay, now 12. What am I looking for? How many of a kind? 4. 12, let's do 12. What
3, 2,
breaks 2 times 2 times 3 is 12. And 27 is 3 times 3 times 3. Do you guys see 4 of the same number?
Yeah.
There's 4 3s. What do I do with this 3 and this 8? What do I get? Okay, so 24 is the number. And what stays inside of the 4th row? 4. Does everyone understand that part? Okay, now, count my x's. How many x's are left? 9. I got 9 x's, x to the 9th. Now, if you want to write 9 of them out, go ahead. 1, 2, some of you can do it in your head. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I need to group 4 of them. There's 1, and there's 2. So it's x squared. What's left? A little old x. That's going to go inside. And how many y's are left? There's 6 y's. So you have 6 y's.
Y squared.
Y to the 6th. So you have y, 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 y. I'm going to take out 4 of these,
Sorry, Nick.
and you get y squared. Okay? Make that small. Actually,
Six or home.
Yeah, we're
Where did, this.
where did we get the 24?
You
Let's
got
go back.
The 2 and the 4. that
The
you-
2 and the 4 were 8.
and the
So there was 8 already out.
And you pull.
And then we pulled the 3, there was 3 that we took out of the 12 and the 27. So 8 times 3 is 24.
Put a dot 3 there so you can see where you put
That 3 is that. Does that help you? Yes.
Why is it y4? Because for the x's, like you took out 2 groups, so you need an x squared, but you only took out 1 group, so it would just be y.
Yeah, it is y. That's the 4th row.
Oh.
Are you talking about that right there?
Yeah.
That's the 4th row. Sorry, my pencil's like,
So the exponent on that y is only 1.
it should look like, here, let me write it nicer. It should be 24, let me write nicer. 24x, my pencil lead is not,
Sharp.
it's not sharp.
It's not neat.
That should be really small. Is that better? That does not go with that.
Rico, what's your question?
Did you get the 4 by factoring the 12?
This 4 right here you're talking about?
Yeah.
This 4 is these 2.
Alright, yeah.
12 is 2 times 2 times 3, and 27 is 3 times 3 times 3. So we're looking for 4 of a kind. I got 3 of these, or 4 of these 3s. So this is what is unmatched. I don't have 4, I have 4 left. The number 4 is left.
Yeah, and notice how she's saying I have 4 left. I call the things that aren't circled and pulled out the leftovers. The leftovers go inside the radical expression. Okay?
Okay, so 19 through 24 is homework. We've got one more. I want everybody to do this on your own right now. Problem number 3. This is the last problem. I want everyone to do this. I'm going to do it, and then I want you to check your answer with me.
Come back and do one.
trying to write it nice.
Make your Y's different every time.
I know I do.
Like sometimes when you say
I
problems,
do.
you make them like curly looking.
I know, I write them that way. I don't know what I like better. What do you like better? You know what, I don't like this Y, because sometimes it looks like it can look like an X. If you get sloppy, that's why I like to try and do
I
Y
think
like that.
visually it looks better like where curly
First,
one.
yeah, I agree. All right, can I see a thumbs up if you got this answer?
Double thumbs
Thumbs up. I only see 1, 2, Ms. Burback, how many thumbs are you counting?
You can count me for 2.
I want,
Mitch, are you?
I want all thumbs up.
I'm kind of like tilted and I'm up.
Give your thumb up?
Three,
No?
not, 3
Okay.
not, 4 not.
Okay, let's get all thumbs up. Why is your thumb not up? What's up? Let's get all thumbs up. What's going on? Okay, so, let's go over it. 45 is 3 times 3 times 5. Do you agree with that? And 35 is 5 times 7. So remember, it's square root, so we can do it. So we got 2 3s and 2 5s. 3 times 5 is 15. Do you agree with that? And the 7 is the misfit. Agree with that? Okay, now let's look at the x's. We've got x to the 5th and x to the 1st, so that's x to the 6th. So off to the side, I did x to the 6th here. So if you have x to the 6th, you've got, think of 6 x's. X, 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 you got 6 of them. So you got 1, 2, 3 sets of them, so that's x cubed. Okay, how many y's do you have? 7 of them. You got y to the 7th, so you got 7 of them. Oops. 1, 2, 3, 4, 5, 6, 7. You got 1, 2, 3 sets with 1 left over. You get it? Okay, can I see thumbs up? Who's got it?
My ones that were done are now up.
Okay, 100%. Brett,
I am.
thumbs up.
I've thumbs up in the camera
100%.
multiple
Chris,
times.
thumbs up. 100% of you guys got this. Excellent. Guess what your homework is?
The rest of it.
All the way up to number 33.
Honestly. So similar.
Okay? Now the back side, hang on, because we're gonna do that tomorrow. If you don't, some of you guys are saying, can we not have homework? If you wanna keep going on and finish the back, you can. It's rationalizing the denominator, it's fractions. It's dividing. If you want, that's gonna be tomorrow's homework, the division stuff. Okay, you have 2 days of notes here. So, don't cross them out, because we're doing them. I just wanted to give it all to you at once. So we're done. Brett, you can turn that off, thank you.
Yep, look.